Number 15, automatic engine warm-up management. The second you turn your key or push that start button, your car is already doing something you never asked it to do. It's babysitting your engine. Cold engines are thicker with oil, tighter with metal parts, and genuinely fragile. So without you touching anything, your car's ECU immediately limits how hard the engine can work. It restricts RPMs, adjusts the fuel mixture, and runs the engine slightly rich, meaning more fuel than normal, just to get everything up to operating temperature safely. You don't see a warning, you don't press a button, it just happens. And here's the part most drivers never realize. If you try to gun it before the engine is warm, the ECU is actively fighting you. It's quietly capping your power output behind the scenes like a babysitter hiding the car keys from a teenager. Once everything hits the right temperature, the restrictions lift, and you get full power. Your car was protecting itself the whole time and never said a word.
Number 14, idle speed adjustment. Your car's engine doesn't idle at the same speed all the time. It's constantly making micro adjustments you'd never notice unless you were staring at a tachometer. When you crank the AC, the idle bumps up slightly to compensate for the extra load. When you're sitting in traffic on a freezing morning, the idle runs higher to keep things warm and stable. When the engine is hot and fully warmed up, it drops back down to save fuel. The system doing all this is called the idle air control valve, or on newer cars, it's handled electronically through the throttle body itself. It's measuring load, temperature, and electrical demand dozens of times per second and quietly nudging the engine speed up or down to keep everything smooth. You just feel a perfectly stable idle. Your car is doing the math in the background without ever asking for credit. Number 13, torque vectoring. This one sounds like something out of a racing game, but it's quietly happening in millions of everyday cars. When you go around a corner, your car's brain is measuring which wheels are slipping, which have grip, and how the weight is shifting. Then it does something clever. It sends more or less power to individual wheels to keep you stable and pointed in the right direction. Some systems even apply tiny, nearly invisible braking forces to specific wheels mid-corner to tighten your line. You don't feel it as a jerk or a correction. You just feel the car grip and go where you pointed it. Without torque vectoring, understeer and oversteer would be constant battles on wet or uneven roads. With it, the car is basically cheating physics on your behalf. Every single corner, every single drive. Number 12, fuel evaporation control. Here's something wild. Your car actively stops its own fuel from escaping into the air, even when the engine is completely off. Gasoline evaporates constantly, and those fumes are both toxic and wasteful. So engineers built in something called the Evaporative Emission Control System, or EVAP. When your engine is off, fuel vapors from the tank get captured and stored in a small canister filled with activated charcoal. Then the next time you start the engine and it's warmed up, the ECU opens a valve and pulls those stored vapors into the intake to be burned as part of normal combustion. Your car is recycling its own fumes, silently, automatically, while parked in your driveway. And if that canister or valve ever fails, your check engine light comes on because your car noticed before you did. Number 11, brake bias adjustment. When you slam the brakes, you probably assume all four wheels stop equally. They don't, and they're not supposed to. When you brake hard, the weight of the car shifts forward. That means the front tires have more grip, and the rear tires suddenly have less. If equal braking force hit all four wheels at that moment, the rear would lock up and you'd spin. So your car automatically adjusts how much braking pressure goes to the front versus the rear in real time. This is called electronic brake force distribution, or EBD, and it works hand in hand with ABS. It happens in milliseconds, adjusting every single time you touch the brake pedal. You just feel the car stop in a straight line. Meanwhile, your car quietly ran 100 tiny calculations to make sure you didn't end up facing backwards. Number 10, variable valve timing. Your engine breathes differently depending on how fast you're going and how hard you're pushing it. At low speeds, the engine wants valves that open gently and briefly for smooth, efficient combustion. At high speeds, it wants valves that open wider and longer to let in as much air and fuel as possible. The problem is, valves are mechanical. They can't just change shape. So engineers built systems that change the timing and duration of valve operation on the fly. Honda calls theirs VTEC. BMW calls it Vanos. Toyota has VVTi. The names change, but the job is the same. Your car is constantly adjusting how its engine breathes based on what you're asking of it. That subtle surge you sometimes feel when pushing the accelerator harder isn't a glitch. That's your engine switching breathing modes. Automatically, every time. Number 9. Automatic headlight leveling. Most drivers have no idea their headlights are physically moving, not the beam pattern, the actual headlight units. When you load up the trunk with luggage or throw a few passengers in the back seat, the rear of the car sinks slightly. That means your headlights, which are mounted up front, tilt upward and start blinding oncoming drivers. To fix this, most modern cars use automatic headlight leveling. Sensors measure the ride height front and rear. The system calculates the angle, and small electric motors physically adjust the headlight housings downward to compensate. You load the car, you drive away. The headlights are already corrected. No button, no menu, no thinking required. Some luxury cars do this dynamically, adjusting constantly as the car accelerates or brakes to always keep the beam pointed exactly where it needs to be. Number 8. Transmission torque converter lockup. Automatic transmission cars have a component called a torque converter that sits between the engine and the gearbox. At low speeds, it works like a fluid coupling, letting the engine spin without stalling while the car is still moving slowly. But at highway speeds, that fluid coupling becomes inefficient. It slips slightly and wastes energy. So at a certain speed threshold, usually somewhere around 40 to 50 miles per hour, depending on the car, the torque converter automatically locks up. A mechanical clutch inside it engages and creates a solid, direct connection between the engine and the transmission. Fuel efficiency improves. Engine noise drops slightly. The car feels slightly more responsive. You didn't do anything. Your transmission quietly switched from fluid power transfer to a direct mechanical link and switched back the moment you slowed down. Number 7. Active noise cancellation. You've probably heard of noise-canceling headphones. Your car might already be doing the same thing and you'd never know. A growing number of modern vehicles use a system called active noise control. Microphones placed inside the cabin constantly listen to low-frequency road noise, engine drone, and tire rumble. The system analyzes those sound waves in real time and then plays opposing sound waves through the car's speakers to cancel them out. Not music, not white noise, precisely engineered counter frequencies. The result is a quieter cabin without extra insulation weight. Honda, Nissan, and Kia are among the manufacturers that have used this technology in mainstream cars. So the next time your car feels surprisingly quiet on a rough road, check if your audio system is secretly doing double duty as a noise assassin. Number 6. Electronic stability control intervention. Here's one that works so fast and so subtly that most drivers never feel it doing anything. Electronic stability control, or ESC, monitors your steering input, your actual direction of travel, and your speed simultaneously. The moment those three things disagree, like when your rear end starts sliding left but your wheels are pointed right, the system intervenes in milliseconds. It doesn't ask, it doesn't warn you first, it just selectively brakes individual wheels and sometimes reduces engine power to pull the car back in line. In most cases, it happens so quickly and so precisely that you feel nothing unusual. The car just goes where you pointed it. Studies have shown ESC reduces fatal single-vehicle crashes by up to 49%. It's been mandatory in new US cars since 2012, and most of the time, you never knew it was there. Number 5. Battery charge management. Your car's charging system doesn't just blindly pump electricity into the battery at full power all the time. It's smarter than that. The alternator is managed by the ECU, which monitors the state of charge, the electrical load from accessories, and even the engine's current workload. When the battery is low, the system increases charging output. When it's topped up, it backs off to reduce the load on the engine and save fuel. Some modern cars go even further with regenerative alternator management. They deliberately let the battery drain slightly going uphill, then recover energy going downhill by ramping up alternator output while the engine load is lower. The whole thing happens invisibly, constantly balancing electrical supply and demand while you're just thinking about where to park. Number 4. Adaptive fuel trim. Your car's engine doesn't run on a fixed fuel map. It's constantly learning and self-correcting. Two sensors called the short-term and long-term fuel trims track how the engine is actually performing compared to how it's supposed to perform. If the engine is consistently running lean or rich, the ECU doesn't just flag it and wait. It adjusts the fuel delivery in real time and even saves those adjustments as a new baseline for future use. Essentially, your car is recalibrating its own fuel system every single drive. It accounts for altitude, humidity, fuel quality differences, and gradual engine wear. A car running on cheap fuel in humid summer conditions is operating on a different map than the same car in dry winter air. Your engine figures that out on its own every time you drive. Number 3. Automatic mirror dip on reverse. This one is small but brilliant, and a shocking number of drivers don't realize their car is doing it. When you shift into reverse, many modern cars automatically tilt the passenger side mirror downward. The angle changes so you can see the curb, the gutter, and the rear tire as you parallel park. The moment you shift back out of reverse, the mirror returns to its normal position without you touching anything. Some systems let you save your preferred dip angle through the settings menu. Others just do it at a factory default angle. Either way, the car detected your gear change, sent a signal to the mirror motor, and corrected your view automatically. Most people think they just have good spatial awareness. Their mirror was helping the whole time. Number 2. Start-stop system fuel cutoff. Most drivers with start-stop systems notice the engine switching off at red lights. But what almost nobody realizes is how much is happening in the half second before the engine restarts. When the system detects your foot lifting off the brake, it doesn't just crank the starter motor like a cold start. That would be too slow and too rough. Instead, the ECU monitors exactly which piston stopped and in what position. It then uses the starter motor and sometimes a burst of fuel injection to push that specific piston to the ideal position for a smooth, instant restart. The whole sequence from brake release to running engine can happen in under 400 milliseconds. Engineers also reinforce the starter motor, battery, and valve train on start-stop cars because this cycle can happen hundreds of times a day. You lift your foot. The car has already done the math. Number 1. Predictive shift logic in automatic transmissions. Modern automatic transmissions don't just react to what you're doing right now. They actually try to predict what you're about to do. Using a combination of throttle position, vehicle speed, road grade sensors, and GPS data in more advanced systems, the transmission's control unit builds a picture of your driving behavior in real time. If you're accelerating aggressively, it holds gears longer. If you're coasting down a hill, it preemptively drops a gear to use engine braking before you even touch the brake pedal. Some systems track GPS elevation data and downshift before a descent even begins. Others learn your personal driving style over time and adjust shift points accordingly. You think you're just driving. Your transmission is reading you, reading the road, and staying one step ahead. Every single mile. We hope you enjoyed this video. Here's another one you'll love. As always, thanks for watching.